Hi folks, I'm sorry I haven't been here in a while. I'm a little under the weather and I'm not sure what's going on. But anyway, I've got to get back to this Sansui 9090 dB. What I'm doing right now is I'm changing out the metering lamps. You can see I've done this one already. It has the yellow wires. These are the bulbs I got from Dojo. Dave does really good work. And somebody suggested that I put his URL on the page for the video, so I'm going to do that this time. Excuse me. So anyway, we have to pull out each one of these metering lamps and replace it. The rubber grommets are very old. You have to be extremely careful getting them out. When I get them out, I usually put a drop or two of this K cleaner revitalizer, and it makes them a little more supple, less likely to tear or be damaged. Also, I have read anecdotally it's a good idea to replace these 10 ohm resistors that are on the board, so we're going to do that too, and we'll talk about that as I do it. Anyway, I'm going to pry out one of these lamps, and we're going to do the same thing we did with the lamp board, and that is simply put the iron on the wires and pull them out, and then clean up the holes and put the new ones in. So let me get set up to do that, and I'll show you how I do one, and I'll do the rest off camera. Okay, so I got to wear my visor so I can see what I'm doing so I don't melt any wires. But I'll try to keep my head out of the way, but basically you can see I've grabbed one of the wires with needle nose, and then I have to go in here and just simply melt the solder so we can pull them out. And just make sure I'm heating the right one. Okay, I think these wires are twisted. And I put it in manual focus so that the autofocus doesn't give us all, and very common for these simply to break off because they're very old. But that's okay, we are replacing these lamps, so if the wires break off of them, that's fine. Okay, so we've got them unsoldered. So now we just take the desoldering gun so we can clean them up. Now the holes are cleaned up so we can put the new bulb in. So we just take one of our new lamps and we can cut most of the wire off. Dave's really generous with wire, but we don't need that much. So we just take one of the old lamps, like so here, and we just measure. We'll cut it to about down here. Like so. And then we have to strip them. I use a pair of strippers like these. Again, I just don't see that well, so I've got to use my visor. But it makes things a lot easier to deal with. Okay. Since this is stranded wire, it's a good idea for us to just take a little bit of solder and tin the ends here. And this way they don't give us a problem when we're trying to put them through the board. Okay. Alright, so we just do that. And that'll make them a lot easier to deal with. So now we got to get the old lamp out. And I take a small jeweler's screwdriver like this, just carefully work it around. Like I said, this rubber is really old and you don't want to stress it anymore, and you absolutely have to. Alright, and as I dropped the lamp, at least it didn't fall anywhere I couldn't get it. Okay, so this is what the lamp assembly looks like in the rubber grommet. like that. So we just have to pull the lamp out of here and get the new one in. This is when I take a moment and put some of this rubber revitalizer on these. Stuff smells like petroleum distillates because I imagine that's what's in here. We just put a little bit on and look all over the bench for a rag. No problems. This is where old gym socks go to die. They get a hole in the toe and they go under the bench in the rag box. Okay. All right, that looks pretty good. Like I said, these are pretty old and they're just not as supple as they used to be. All right, so we get our new lamp and we push it through here like so. And then we have to get it all the way in. Okay, so we get it like that. And now we can put it back in and solder it to the board. Like I said, I'm only going to do one of these on camera. It's fairly tedious. And I like to keep the videos within half an hour. What we're going to do is after we get this board, we're going to drop this board and this board so we can replace capacitors and clean switches and pots. Now I don't recommend this, but there's a guy on the internet who goes by the Emperor of Test Equipment, and this guy is allegedly completely self-taught and utterly brilliant. He does test equipment repairs that are far beyond my skill set. But one thing he does, and again I don't recommend it, is he cleans switches with carburetor cleaner. Now anybody that's old enough to have dealt with this stuff knows just how caustic and nasty it is. He works in his basement. I can't imagine spraying that stuff inside an enclosed area. And if it gets on anything, it'll literally destroy it. Back when I drove a car that had a carburetor, I used that stuff. It's got an extremely powerful spray, and the varnish would just literally get sucked into the carburetor, and you'd see it come out the exhaust pipe. It was vile stuff. Probably causes 20 different kinds of cancer, but I'll bet it does work well if it doesn't destroy everything. Again, not recommended and not what I'm going to be using, but I just thought it was an interesting anecdote. So anyway, let's get this back in. I could unsolder all this and it might make it a little easier, but while it may be somewhat like building a ship in a bottle, it's a lot easier for me to simply do it in situ with them still wired in. Then we can put it back together and start working on the rest of this. So I need to get under here and feed these wires through the holes and solder them in. I'm going to pause us for a minute so you don't hear me cursing under my breath. Okay, so I've got the other lamp in. Got it in the socket, put it in here, soldered it back in. Now, I did hear anecdotally it's a good idea to replace these 10 ohm resistors, so we're going to pull those out. And again, I'm just going to do one on camera, do the other one off, because if you've seen one, you've seen them both. Okay, so that should get that out. They measure okay in circuit, but while we're in here, it just doesn't make any sense to not do something. These are very inexpensive components to replace. I buy them literally by the 100. So we'll just replace these guys. Did I get all the solder out of there? Yes, I did. Okay. Well, they look like they've gotten a little overheated, but I think it's probably okay. And if I measure it, it's probably going to measure fine. And it does, 10.1 ohms. So I'm going to replace these. I'm going to show you a little tool I have for putting those kinks in to create standoffs. So let's see, 10 ohm. All right, and those are 1/4 watt. Okay, so we're going to replace them with these metal fill. And I'm going to show you real quick a tool I have for making those little kink standoffs. Kinky standoffs? I'm not that kind of guy. Anyway, we take our resistor, we bend the leads 90 degrees like usual, and then we take this guy, and let's see, and I always get this wrong. I have to do it at least twice. We just do this, we bend the leg back here, and you can see it makes a nice little bend there, and that is how we get those standoffs. I don't recall what this tool is called. I'll see if I can find out what it's called, and I'll put it on the page along with the link to Dojo. But anyhow, that's how you get these standoffs on, and we can put this in. I'm going to turn the camera off. I'm really fatigued, and I'm not doing my best work here while I'm distracted by the camera. Okay, so I've replaced both lamps and the resistor here. You can see we have yellow wires here, and a new resistor. I'm going to do the other one off camera. I'm really flagging here, but we'll take care of that, and then we're going to drop these boards and start working on those. Okay folks, I've got the lamps all installed, the meter assembly reassembled here. So if you look down in here, we should be able to see all four of those bulbs illuminated. There was one out when I received this unit, and you should be able to see there are four distinct lamps glowing there, which is for the pop out of protection. Incidentally, for those of you who don't know, you can test incandescent bulbs just by using your ohm meter. A good incandescent bulb should be anywhere from just a few ohms to maybe up to 20 something. This is a new lamp that I got from Dave, and we just hook it up to the ohm meter, and you can see it just shows you 11 ohms. This is one of the ones I took out, which tests bad. As you can see here, we have an open circuit. An incandescent bulb is nothing more than a filament that you run current through and it glows brightly, so if it's open, it's not going to work. You can test LEDs by going to the diode function, and they should glow just a little bit, but you have to get the polarity right, because it does matter with LEDs, does not matter with incandescent bulbs. Okay, next step we're going to take is we're going to take the filter board out. I took the two screws out the front, so this should just come out. And we are going to replace these capacitors, and most importantly, we're going to clean these switches. It's really tough to get anything into these because they're sealed pretty well, but we'll get some deoxit in there and work these. This shouldn't take long. Then we're going to go to the tone control board where we have pots and switches to clean and several capacitors to change out. We will check the transistors to see if there are any on the hit parade that get changed on site. You can't trust the service manual for this. You have to see what's actually installed in your unit. There are often changes that come between the service manual being released and then subsequent revisions, so you always have to check the boards themselves. That's why when we got to the driver board, nothing was making any sense. And thank goodness that Tolly had come out and re-engineered the schematic. To get a replacement board, he refers to it, or you may have heard, the Tom and Tolly board, or Tolly Tom. Tom was an audiophile or an audio guy that got in touch with Tolly, and they worked together to create that board. And I don't believe I had attributed to him before, and I apologize for that. But anyhow, you definitely have to check what you actually have as opposed to what the service manual shows. They are often right, but not always. Okay, the filter board was a pretty simple proposition here. So I've got film caps replaced for the low leakage electrolytics. I worked some cleaner in around the shafts, about the only place you can. And then you just have to work the switches, get the deoxit in there so it can do its job. And we can put this back in, and now we're going to pull the tone board after that. Okay, so in order to get the tone board out, we have to remove this screw, these nuts, and this screw, and then we should be able to get the tone board to slide out. So let's get those screws out. And we'll get my metric pliers here. That's a joke, folks, no such thing. I always try to make sure to grab only the nut. Not that anyone will see this, but I don't like to scar anything I'm removing. Okay. And yes, this is a nut as well, even if it doesn't look like it. So all you have to do is just break them loose and they come right out. So let's see. Now I temporarily put all this hardware into this dish right here. If it's going to be a few days, if I have to order parts, if I'm going to move on, do something else, I will bag these and put them in the master bag. But this is probably going to go right back together today, so I'm not going to bother doing that. I do have an MO here because I have got myself in trouble in the past. So if you're smart, you will learn from my mistakes. Well, let me rephrase that. If you're wise, smart people learn from their mistakes. Wise people learn from the mistakes of others. So now the board should just come right out, and it does. And I left the filter board loose, so we'll have a little more slack to work on this. But we need to clean switches, we need to clean pots, and we need to replace these and take a look at the transistors to see if they are on the hit parade. Okay, so I've gone through the tone board. I sprayed everything out. I sprayed contact cleaner on the switches and fader lube in all the pots and worked them. Anyone who watches channels like this on YouTube is probably familiar with Mr. Carlson's lab. I'm a big fan of Paul Carlson. He's probably 20 years younger and 20 times smarter than I will ever be. And one of the things he mentioned is to spray pots, and he didn't mention switches, but I'm going to assume that the same applies. He said spray a pot, work it, wait 24 hours, and spray it again. His theory being that in that time period that the solvent will loosen up any additional crap in the pots, and the next application will help flush it out. So that's what we're going to do with this. I've sprayed everything. We're going to put it back in so we can test it out, but I'm not going to put all the screws in because it's going to come back out so we can get access to everything and spray it. On the side here, you can see that we have replaced all the electrolytic capacitors, and all the small values of low leakage capacitors were replaced with film capacitors. Now, something I want to point out about those, it's easy to see this orange jacketed capacitor is a low leakage cap. However, modern replacements are not. I bought these from Mouser. I marked the bag LL for low leakage because you can't tell by looking at these that these are low leakage, whereas the orange jacketed ones are always low leakage. So I wanted to mention that. And the other thing is, there were two transistors, pardon me, on this board that were changed out. They are C1313 or 2SC1313. These are known to get problematic with age. I have a list I got from a popular audio forum that was compiled by member D. Lucy, and it's been a really valuable resource. There's some that just replace all the small signal transistors. I don't, because there's those who believe it may change the sonic character. I don't. The sonic character comes from the circuit topology, not the parts. That's why people that claim that certain brands of capacitors will sound certain ways, I give little or no credence to. I simply don't believe that. I do believe that people have replaced bad capacitors with new good capacitors and heard a difference. That I can believe. Replacing bad with good, yes. One brand to another, sorry, no. But since I replaced these, I want to point out that the generally accepted replacement for the 2SC1313 is the KSC1845. However, This transistor pins out collector, base, emitter, and the 1845s that I replace them with pin out emitter, collector, base. So you can't go by putting them in the same orientation, flat side facing the same way. They actually have to be opposite when you replace them with these. So those are a few things that can trip you up. I just wanted to point out. So I'm going to slide everything back into place here so that we can test it. And then I think that'll probably be it for this video. I'm still not quite right, so I don't want to push it, but I have to get this finished up. The next things we're going to do are get at the other controls, and we are going to do the Dolby board. And I'm going to talk about that really briefly, but the Dolby board is one of the first, if not the first, circuit boards that Sansui made that are double-sided. Now, most circuit boards like this and in older stereos are all single-sided boards. That means that they take a board like this that is completely coated with copper on only one side, they etch away the unwanted copper, and that leaves the traces that they use for the circuit paths. Well, as time went by, they realized they could actually use both sides of the board and have a much more versatile, much more compact board. However, the problem with the Dolby board on these, and that's this guy up here, the problem with this is that there are through holes that connect the one side of the board to the other, and the through holes become problematic. So people do what they call repinning the board. And what that boils down to is you have to clean all the old solder out of a through hole. I'm not sure if this is one here, but let's just say it is. Clean the solder out and put a component lead in there and solder it in, and then solder the other side. Which is why when I put these capacitors in, we're saving these leads. They're going to come in handy when we get to this board. As time went by, they went not only from single to double-sided boards, but a lot of test equipment manufacturers, notably Tektronix, began to create multi-layer boards where you had traces that were sandwiched inside the board. And those can also cause some real headaches to troubleshoot, and sometimes you have no choice but to replace the board. Okay, so I'm zoomed in on the scope now. I'm feeding a square wave in because the square wave is how you determine frequency response and issues. So if we just turn our amplitude up, you'll see we have something that approximates a square wave here on each channel. And I'm going to turn the bass. That's all the way down. That's all the way up. Now, if you recall when we talked about square wave, a good square wave should have rapid rise and flat top. The top being flat is a function of low frequency response. Closer to DC, the better. So you see the slope that we're getting there is because we're manipulating the bass control. Now, if we manipulate the treble control, you'll see that we have a overshoot when we turn it up and undershoot when we turn it down. And our mid falls somewhere between the two here. Okay, so I'm going to flatten this out. Let's see. More or less here. And then we'll try the filters. This is our low filter, and you can see that filters out lows. High filter rounds off our corners, right? Okay, and the last one is our 20 dB cut, and it does cut. So all our tone controls are working. Now I have a confession to make, and I have to laugh when I say this, but when I initially tested this out just with a sine wave to make sure it was passing signal, I had another 180 degree phase shift, and I didn't have enough output on the left channel. So I took a quick look at my work, and I did exactly what I told you folks not to do. One of the transistors, remember I said there's a difference in these guys, the way they pin out. I had one in backwards, and A funny story about that. A gentleman named Nelson, who lives down in the next county, brought me a Sansui AU717. He was having some problems. He had rebuilt it, and he did absolutely flawless work. The craftsmanship was top notch, but he doesn't have test equipment or the knowledge to use it, so he brought it here to find out why it wasn't working. Main problem was offset. I didn't check the phono, and that's on me, because he had one channel out on the phono because there were a couple of transistors that were in backwards. And he made the comment, oh, well, you're a professional. And the next time I put one in backwards, because we do make mistakes, I had to send him a picture of it going, yeah, this is what the professional did. Folks, we all make mistakes, all right? I happen to have the skill set to be able to find my own screw-ups. If only I could find them in the rest of my life. Anyhow, I'm going to cut this video here. I got to go lie down. I don't know what's wrong with me, but anyway. I want to thank everyone for watching. And as always, I like giving back to the community that's given me so much. Thanks a lot, folks.